Hi everyone, I am Vladimir Somers. So I'm working as a computer vision and deep learning engineer at Synergy Sport, which is a division of SportRadar. And I'm currently pursuing a joint PhD with the UCLouvain, which is a university in Belgium, and the EPFL in Switzerland. So similar to yesterday, this tutorial is supposed to be casual, so feel free to interrupt at any point to ask your question and interact with me. So for the next hour, we will do an overview of everything you need to know to start competing in the SoccerNet Re-Identification Challenge. We will start with a brief introduction to the research field of person re-identification. And for the rest of the presentation, I will often use the shortcut ReID to refer to person re-identification. I will then introduce our new SoccerNet dataset for player re-identification and explain the difference between this dataset and other popular ReID datasets that are used for mainly for street surveillance, such as the famous Market 1501 dataset. I will also tell you a little bit more about the metric we use to evaluate the performance of your ReID model and the strategy used to rank participants in the challenge. And we will then leave the slideshow, and I will do a quick overview of the GitHub repository and the dev kit, but also the dataset structure, and so that you can start working on your own solution as fast as possible after this tutorial. And finally, I will do a quick recap about challenge rules, money prize, sponsors, etc. And I will also tease you the current status of the leaderboard. And at the end, we will do a quick Q&A session and a coffee break before the start of the next tutorial. So let's start with our task. So what is exactly person re-identification or ReID? So person re-identification is a person retrieval task. This means that we are given a person of interest, which we call a query. This is the goalkeeper in yellow that you see on the left. And the goal will be to find occurrences of that person among a set of candidates, which we call the gallery, and which is represented by all these images scraps of soccer player in the middle of the figure. And hopefully, in the end, if you manage to develop an efficient ReID model, you will get as an output all images depicting the same player, the same identity. So how is that person retrieval task performed? So in practice, re-identification methods output a kind of similarities metric between pairs of images. And this similarity metric can be seen as a distance between images. So a small distance means that we are facing similar samples, similar images, and a big distance means that we are facing different samples. And we will therefore compute the distance between the query and each image in the gallery and rank these gallery images according to their distance to the query. In this figure, the top of the ranking is on the left and the bottom of the ranking is on the right. And hopefully sample from the same identity as the query will be on the left, so at the top of the ranking. In this figure, you can see that a green border illustrates a correct match, so sample with the same identity as the query, and red boxes, samples from a different identity than the query. So because we perform the retrieval task using a ranking and a similarity metric between samples, we can conclude that ReID is a representation learning task, and more precisely, a metric learning task, or even a deep metric learning task, as we are using deep learning to learn the similarity metric. And so deep metric learning means that each sample in the dataset will be processed by a feature extractor. This is what you see on the bottom left of the slide, for example, a ResNet 50, to obtain a feature vector as an output or an embedding. And that feature extractor, it will be designed such that samples with the same identity are close to each other in the feature space, in the embedding space, and samples with different identities are far away from each other in that space. The embedding space or the feature space will therefore have the property of forming clusters of samples with the same identity. This is what you can see here with the simple illustration on the right. So hopefully, in the end, you will obtain a nice feature space, such as the one in this illustration, which is an illustration for the famous Marken 1501 dataset, where you can see that sample with similar appearance and hopefully with similar identity are close to each other. Now, how do you train a ReID model? In the past few years, researchers have been experiencing with several training strategies for ReID, and some of the most used ones are represented right here. So, for example, on the bottom left, on the top left, you have the identity loss using a classifier and a cross-entropy loss. You also have a kind of contrastive losses with Siamese network. For example, the verification loss on the bottom left or the triplet loss on the right. And nowadays, most state-of-the-art methods use both the identity loss and the triplet loss together for training ReID models. And the baseline that we use in our dev kit uses actually both the identity loss and the triplet loss, similar to those state-of-the-art methods. If you want to learn more about different training mechanisms and have a quick introduction to state-of-the-art method to ReID, I suggest you have a look at the paper that I just mentioned here below. So this is the end of the quick introduction to the research field of person re-identification. And if you want to learn more about it, I gathered here a few interesting resources to get started with. So above you have a few interesting frameworks, the most used one in ReID. And actually our dev kit is a fork of the one at the top, so Torch ReID, but we will come back to that later. Just below, a few interesting links with actually awesome list with nice ReID papers from top conferences, recent papers, also other ReID dataset, which are generally about street surveillance. And here a few two interesting paper. So the first one is the one I mentioned just before, deep learning for person re-identification, a survey and outlook. This is a very nice recent paper introducing the field of ReID, talking about metrics, dataset, the different state-of-the-art method and approach used to solve the task. And just below, bag of trick and a strong baseline for deep person re-identification. So this is a very, very popular paper on re-identification, which basically introduce a baseline producing state-of-the-art performance. And that kind of baseline will probably be a good starting point for you to start with the challenge. So now that you understand what ReID is all about, let's have a look at our SoccerNet ReID dataset. So the SoccerNet ReID dataset was built using the main full-frame SoccerNet dataset. And in this data set, we have actually an astonishing amount of 14,000 soccer actions. And each action is actually made of multiple frames. This is what you see in the GIF on the slide. So among those multiple frames, there is the main action frame. This is the first time you see an action in a soccer broadcast video. And then the replay frames, which are replays and are often slow motion or different camera views than the first action frame. But these replay frames depict, of course, the same soccer action. For each action, we annotated the links between all bounding boxes from the action frame and the replay frames in order to spot bounding boxes belonging to the same player. And this is from these links that we generate our identity label for the ReID dataset. So the process that I described just before, we repeated it for all the 40,000 actions. And these 14,000 actions come from 443 soccer games. We have on average 17 identities per action and 1.54 bounding boxes per identity. In total, we have more than 376,000 bounding boxes, which is actually 10 times bigger than the ReID dataset market 1501, for example. So this is a quite huge dataset actually, as compared to other standard ReID datasets. So there is a super important thing that you have to be aware of regarding our SoccerNet ReID dataset. Actually, identity labels are only valid within one action. So, for example, in the action here in the slide, you can see the player Di Maria, Angel Di Maria in red. And let's say we have another action from the same game, or even another game where there is also Di Maria. Then images of Di Maria from that other action will be labeled with a different identity than the one we use in this action here. So this means that an identity label in the dataset is not global. It is only valid within the corresponding action. And the conclusion about that is that images from the same player but from different actions are therefore labeled with a different identity. As we will see later, this is not an issue at a testing stage for evaluating performance, because we will only compare images coming from the same action. However, for the training stage, it can be negative on performance to have such property. And it's up to you, the participant, to find strategies to mitigate the effect of such border cases. Here is a small table with some interesting stats about the SoccerNet ReID dataset. So you see that we divided the dataset into 4 splits, 4 sets. There is a train set, which is used for training and doesn't have a query and gallery split because, as you know, splitting the dataset into queries and gallery is only useful at inference when you want to evaluate the performance of the model. So this is why it is not done for the training set. Then we have a validation set, which is used for hyperparameter tuning, and so evaluate the performance of the model. So there is a query and a gallery split. Then the test set that you can use to compare different strategies, or even put some numbers in your paper. And finally, the challenge set that you see on the right is the set that will be used for ranking participants. And so all the labels and the ground truths related to that set are kept private, and you are not provided with those labels. So now I want to do a quick recap of the methodology we use to build the set that are used at inference. So I'm talking about the evaluation set, the validation set, the test set, and the challenge set. And the process that I describe here will be applied individually on each of the 40,000 action. And of course, as an example, we will have a look at one specific action here. So this is the action 12 from a Bundesliga game between Bayern Munich and FC Köln. So as I told you before, an action is made of an action frame that you see here on the left, and one or more replay frame. Here we have 4 replay frames for that action. And for each frame here, we have a list of bounding boxes that are illustrated in yellow. And so for the query and gallery split, we simply decided to keep all images from the action frame as queries. This is what you see on the left. And then to keep all the bounding boxes from the replay frames as gallery samples. So what you see on the right. It's very important that each query has at least one match in the gallery. And this is why we decided to move bounding boxes from the action frame with no match, such as the referee that you can see here. So we moved such samples to the gallery set. And so those samples, they are used as a distractor in the gallery. And of course, all other queries, such as the one in blue here, have at least one match in the gallery. So once we obtain the query and gallery split for a given action, your model will be evaluated on its ability to perform a good query to gallery ranking for each of the query. So here is an example of a ranking computed for the first query, so the goalkeeper in yellow. We will see in the next slide which metrics are used to evaluate the performance of the model for such a ranking. And the process that you see here for ranking the gallery according to one query is repeated for all the queries in the action. And after, the process is repeated for all the actions in the dataset, so all the set. To evaluate the ranking performance of a RIA-ND model, we use 2 very popular metrics, which are the MAP and the rank 1 accuracy. So MAP stands for mean average precision, and it is used to assess the average retrieval performance considering all the samples in the ranking. So the maximum MAP is reached when you have all the correct matches. So all the green boxes that you see above. So when all those green boxes are at the top of the ranking, and all the incorrect match, so the red bounding boxes, are at the bottom of the ranking. And this is the MAP that we use in the leaderboard to rank participants. After that, we have the rank 1 accuracy, which is actually comes from the cumulative matching characteristic, so the CMC curve. And we keep only it at the first rank position. And so that rank 1 accuracy, it's actually a way to measure the probability that the correct match appears at the top of the ranking, so the top ranked sample. If you want to learn more about these 2 metrics, please have a look at the link I put here below. And this is the paper about So a survey and outlook about person re-identification that I already mentioned previously. So here is the final discussion about our new SoccerNet Re-ID dataset. We list here the specificities of our dataset compared to other popular public Re-ID datasets that are generally used for street surveillance. So first of all, our datasets do not contain pedestrians in the street, but soccer players and referees on the soccer pitch. And because we are in a team sport context, different identities might have a very similar appearance in the dataset, which renders, of course, the re-identification task very hard. Also, we have few numbers of samples per identity compared to other datasets. Again, identity labels are not global to the dataset. This is what I explained previously. And those identity labels, they are only valid within a given action. Also, because we look at a specific action and its replay frames in a broadcast soccer video, all samples from one identity are captured at roughly the same time instance, which means that samples from the same identity have a very similar pose. But of course, those samples are captured at different camera angles. And finally, there is a big diversity in image resolution because some images are actually crops of very small bounding boxes in a panoramic view of the pitch, and image resolution for these crops is therefore very low. So now we will leave the slideshow for a few minutes, and I will do a quick tour of our GitHub repository and our dev kit and the baseline model. So here, I just want to do a quick tour of the GitHub repository. So everything that I just explained is also written in the README of the repository. So I really suggest you to have a look and try to understand all the information right here. A little down below, you will find the instructions to install the dev kit. So this is a simple git clone and an installation of the Conda environment. All the instructions are just right here. And so I will switch to my PyCharm IDE. So this is the cloned repository with the README. So this is what you obtain after following those instructions. And the final step, if you want to use the dev kit, is to run that command line, which will launch the training of the baseline. So as you see here, the main entry point for running the model is the main.py file that is here in the benchmark and baseline folder. And you have to give as an input to that file a configuration file, actually a YAML configuration file. Here we already provide a basic baseline as a YAML config, which is right here in the repository. If we have a look at that configuration, you will see that we have a few configuration and parameters, and actually those configuration are extension of everything that is defined in the default config.py. So in that file, you have all the configurations for the Torch Re-ID framework, and everything you write in the YAML file will actually erase or overwrite what is defined in the default configuration here. If you want to learn more about the different configuration, you can look at the comments, where you have most of the time a brief description of the configuration. You can also have a look at the Torch ReID documentation. So I put a link in the README to that documentation, which is right here. It's really well written. You will learn more about Torch ReID, for example, how to display the ranking that you obtain in the end. So a very useful tool to visualize your results. So if you come back to the baseline config, we start with the model. Here we use a simple ResNet 50 with a fully connected layer for dimensionality reduction. We define here the data set. So once you run that baseline model, the data set will be downloaded automatically. You don't have to do anything. If you want to download the dataset manually, there are instructions in the README to do so. And the dataset will be actually downloaded under the dataset folder right here. Just below, this is where you define the source and the target dataset. So the source is the dataset on which you will train your model. The target is the dataset on which you will test your model. Here, the SoccerNet v3 dataset is the class in which we embed the training set, but also the validation set. So in the SoccerNet v3 dataset, this is where you have the validation sets and the training set. So most of the time you will, so if you use SoccerNet v3 as a source, the model will be trained on the training set. If you use SoccerNet v3 as a target, the model will be evaluated on the validation set. If you want to evaluate also your model on the test set, you will have to provide that source, that target dataset, and the same for the challenge set, which is right here. As I mentioned before, the SoccerNet dataset is a very, very big ReID dataset. And for a research purpose, it might be easier to only train your model on a subset of the dataset. And this is what can be achieved with that configuration. So here, for example, the model will be trained on 1% of the training set for faster training. Here we define the loss. So we use the triplet engine, which is actually a soft, so the identity loss I mentioned before, plus the triplet loss, and the identity loss. So this is a soft max with a label smoothing. Here you define training parameters. And finally, the test parameters. So here we want to compute the rank 1 accuracy. This is what we define right here. And finally, the export ranking result. So this is a configuration to export as a JSON file your ranking results on the test set or on the challenge set. And so I will show you in a few minutes what that JSON file look like. And so for the baseline that you see on the leaderboard, we use 40 epochs, that batch size, and we train the dataset on 2% of the training set. This is the configuration for the baseline on the leaderboard. So with that baseline config YAML, you run the command I just showed before. And I will not do it right now because it's quite a long process to train that model. Here are how the output of the logs look like. So first, you have a print of all the configuration. Here, a description of the different datasets used and metrics about those datasets. Then you have all the training epochs that are displayed. And finally, the output result for each target data set. So as a reminder, we had the SoccerNet V3, which is actually the validation set, the test set, and finally the challenge set. For the test set and the validation set, you can see the performance metric, because for these two sets, the labels are public. So you are provided with a label in the downloaded dataset. But for the challenge set, the labels are private. This is why you don't see the performance of the model. But as you can see here, we used the configuration to export the ranking results. So as a reminder, it was that configuration we set to true. And as you can see, the final distance matrix was exported to that JSON file, which looks like this. We don't have that much time left, so I will briefly explain the format of that JSON file. So this is a two-level JSON file. The first level are keys corresponding to the index of the queries. So you have the first query here, and if we go to the bottom of the JSON file, the last query is here. And so for each query, there is a list of all the gallery samples from the same action. So here you see that for query 0, these are the only samples in the gallery that come from the same action. And here we provide the ranking for those gallery samples. So 0 being the first gallery sample in the ranking, and 1 being the last gallery sample in the ranking. And so this is the JSON file that you have to upload on the EPFL platform to participate in the challenge and get your evaluation metrics. So here is a screenshot of the leaderboard on the challenge set. So this is a screenshot we took a few days ago. And actually, since that screenshot, there are already a few new submissions with new teams. And actually, there is a new first team in the leaderboard. So there is actually a lot of submission recently. So if you see your solution in the leaderboard, please update it soon with better result, because there is a newcomer at the top of the ranking. Here are so a few instructions about the challenge. So the winner will be announced at the ActivityNet workshop CVPR 22. And you can see the deadline for submitting your solution on the EPFL platform. So it is in 1 month. And the money prize of $1,000 will be given to the winner by Synergy Sports, so the company that I'm working for. So Synergy Sport is a division of SportRadar, and at Synergy Sport, we are interested in sport data and analytics and general sport video understanding. And so we do a lot of research similar to the SoccerNet Challenge, and we are always looking for more talented computer vision and deep learning engineers. So if you want to learn more about the company or job opportunities, feel free to send me an email with the email address right here. So here is a copy-paste of the eligibility rules that Anthony presented yesterday. So if you want to know more about those rules, please have a look at the GitHub or at the tutorial from yesterday, the first tutorial. About the technical report, here are also the rules. Again, please have a look at the GitHub or the tutorial from yesterday. So the deadline is June 6th. And the goal of that report is for us to understand your result, to be able to reproduce your model, and we will use that technical report to evaluate if your team is, of course, eligible for the prize money. So we are reaching the end of this tutorial, and here are a few take-home messages for you. So first of all, try to design methods that are adapted to the specificities of the ReID dataset. So these are the specificities that I mentioned just before. So please make sure that you understand them. Secondly, you will find a link to our Discord community on the GitHub README. Please do not hesitate to join, ask your question, and discuss with the community. And finally, I hope you will enjoy this challenge as much as we enjoyed actually building it. So thanks for your attention. And if you have any question, it's the time.